everyone and Assalamualaikum. So we are already at chapter 3 electrochemistry. So in previous week we already covered 3.1 galvanic cells. So this week we will cover 3.2 and 3.3. 3.2 Nernst equation. Learning outcomes. At the end of this lesson, students should be able to first write Nernst equation for a given galvanic cell. So second one is explain the factors that affect the cell potential. So this is Nernst equation. E cells equal to E naught cells minus RT over NF, ln concentration of product and over concentration of reactant. So bear in mind, it's actually concentration of product and concentration of reactant is actually reaction quotient, which you earlier learned in chapter 6, semester 1. So it shows the relationship between the standard cell potential E naught cells and the cell potential E cells. So what are the difference between E naught cells and E cells? So E naught cells is actually standard condition, okay, while E cells is actually non-standard condition. But we have another Nernst equation which is much more simpler, okay, provided that the temperature is 25 degrees Celsius, okay, which is this equation. Okay, E cells equal to E naught cells minus 0.09592 over N log concentration of product over concentration of reactant. So you can memorize this equation because most of the questions always use this equation. Okay, so what are the terms and constants in Nernst equation? Okay, so R is a universal gas constant. Okay, so you can get the R in the list of the constant values provided in your exam. Okay, right. T is absolute temperature, okay, which is temperature in Kelvin. Okay. N is number of electron transfer in balanced redox reaction. So we have reduction, we have oxidation. Okay, you do the equation, you balance the equation, and then you know what is the number of electron transfer. Okay, F is Faraday constants, charge of one mole of electron, which is 96500 coulomb over mole electron. So now we go for the next learning outcome in 3.2, which is factors affecting cell potential. Okay, so actually the factors is actually all the terms that contained in the Nernst equation. Okay, let's have a look. What we have in the Nernst equation, we have E naught cells. Okay, everything that will change E naught cells, okay, will affect the E cells. Also will affect the E cells. Okay, temperature. Okay, everything that will affect the temperature will affect the E cells. Okay, number of mole and also the Q. Okay, all right, also the Q. R and F will not be the factor affecting the cell potential because it's a constant. Okay, right. So the value of E cell first, okay, is a concentration of reactant and product. Okay, which the concentration of reactant and product will affect the value of Q. Okay, Q. Right. So when the concentration of reactant is more than concentration of product, okay, what will happen is Q is less than 1. Okay, right. So when Q is less than 1, let's say 0.2, 0.4, okay, less than 1, okay, what happened to the value of ln Q? So ln Q, okay, will be less than 0. So this term, okay, when this is less than 0, will be negative value, right? Okay, ln Q will be negative value, right? So when this term is negative value, okay, so this term will be negative value, right? Okay, so negative, okay, times with negative value, okay, so it will add up the value of E naught cell, right? Thus it will increase the E cell. So E cells larger than E naught cell, right? If concentration of reactant is equal with concentration of product, okay, so the Q will be equal with 1. So what will happen to the ln Q? So ln Q, okay, so ln Q will be 0, right? Ln Q will be 0. So this term, okay, this term will be 0, right? So we're not going to increase the E naught cell or decrease the E naught cells. So E cells is equal with E naught cell, right? What happen if concentration of reactant less than concentration of product? Okay, right? So Q is more than 1, okay, ln Q is more than 0, right? So it will be a positive value for this part, right? So it will reducing the E naught cell, right? Reducing the E naught cell, right? So E cell is less than E naught cell, okay? Right, so another factors affecting the E cell, okay, is temperature, okay, because there's T in the equation, and type of half cell, okay, because type of half cell will affect the value of E naught cell, okay. So we go through for the second factor, okay. Right, lowering the temperature will change the value of E cell, okay, right? If, okay, T increase, okay, right? Sorry for the bad handwriting, okay. T increase, okay, we increasing this value, okay, right? So this term, right, the terms that the value that we deduct from the E naught cell, okay, will be larger. All right, so what will happen to the E cell? Okay, E cell will be reduced, okay. What if temperature, we reduce the temperature, right? If we reduce the temperature, okay, right, we reduce the temperature, okay, the value that we need to deduct will reduce, okay, right? So the E cell will increase, E cell will increase. All right, so that is the temperature factor, okay. So let's look at the third factor, which is type of half cell, okay. So if you want to increase the E cell, right, if you want to increase the E cell, so we have to increase the E naught cell, right? Okay, so in order to increase the E naught cell, okay, so from the formula of E0 cell, okay, from previous week 3.1, okay, E0 cell is equal to E0 cathode minus E0 anode. Okay, in order to increase the E0 cell, the value of E0 cathode need to be increased. Okay, use the half cell with the second point, use the half cell with more positive SRP value, as cathode will increase the E cell. Okay, we try to increase the E0 cell in order to increase the E cell. Okay, the second point is we try to reduce the value that we need to deduct, E0 anode. Okay, so we try to get a more negative SRP value as anode. Okay, so the value here, if the value of E0 cell is reduced, it will increase the E0 cell. Right, so three factors affecting the E cell. The first one is concentration, second one is temperature, and the third one is type of half cell. Right. Alright, so already done the Nernst equation 3.2. Okay, see you on next video for 3.3 electrolytic cell. Thank you.